welcome to the very first episode of the Bug in Focus series. So Bug in Focus is a new series, and instead of looking at kind of beginner level bugs, we're going to be looking at more advanced bugs and breaking them down. And just more advanced techniques in general. So we're going to look at a specific bug class, like we're doing today with remote code execution, a specific target, like mobile, but it's not going to be a tutorial about how to find them. It's more going to be exposing you to them. I'm going to sit and break it down for a beginner so you can kind of understand a little bit about how this works behind the scenes. And we're really going to be talking about some stories about the bug, like how people found them, and kind of some resources on how to learn more about the bug. Not once again as a tutorial, but instead to just expose yourself to these ideas. In my video on the resources and how to become a bug bounty hunter, I discussed kind of a lot about exposing yourself, right, to bug bounties and the community. And I hope that these videos will add on to this exposure concept. So here we have a video about RCE. This is actually about RCE bugs, not clickbait. And although I don't expect you to be able to find one, I want you to be able to sort of pull back the curtain almost, or shine a light through dense fog to be like, look, here's some kind of information about this that's broken down for you to be able to understand it. So that in mind, I picked RCE as our first bug. It's very much a holy grail bug for a lot of people. A lot of people are really interested in them because they're so dangerous, and they also pay really well because they're so dangerous. And a lot of the time, it does seem a bit smoke and mirrorsy. You don't really know what people did. So I've broken it down, and I've actually got some tips on if you are sort of a more advanced hacker on actually, getting started in RCEs and stuff like that. So I kind of hope from this series that you'll gain a certain amount of respect for these bugs and how much effort and time it takes to actually exploit them, but also I hope you find it interesting to see how somebody else thinks about a problem. And especially as I finish up my series on finding your first bug, I hope that with this Bug in Focus and some of the other series that are coming out, that I'm really going to be able to end the first bug series and start working on this more advanced content. And really, I want these videos to grow with you and grow with me as well, because every single time I make one of these videos, I learn more and more about a certain bug. And I'm not that far away from a beginner. I've got a few bugs, yeah, but I'm still not like a super hacker. I'm no Stoke, I'm no Tom Nom Nom. I'm nowhere near that. I am very much slightly above you guys. In the fact that I found a few bugs. So I hope that all of this is interesting and you find it useful. So with talking about RCEs, what is an RCE? And I think a lot of people kind of understand this, but I wanted to start from the scratch. So it's quite a simple concept. The ability for an attacker to run any code on a victim server. Now that's not strictly true, but it's close enough. And what this really gives is an attacker a ton of control over a server. You can copy and exfiltrate files, you can download information about users, you can upload your own malicious code, you can delete files or infect a server with something like ransomware. And as you can see, it's got a really wide impact, but I'm sure everyone is familiar with the mythical RCE. I think it's very much a holy grail bug. A lot of people want one, know them, read articles on them. So I really want to start by breaking this down into what exactly an RCE is. So an RCE is really these two types of bugs: command injection and code injection. So let's go see what these look like. So this is a quick demo I have whipped up in PHP. So here we have some kind of test connection tool. So in here, I've got US West, there's a bunch of other servers, and then we can see we get a ping back, and that's telling us, our result. Now, this is all well and good, but what is it actually doing under the hood? So if we look at inspect element here, and this is something you really should be doing as you become a bug bounty hunter is you should be pressing inspect element first. So we can kind of see we've actually sent ping 8888. So let's change that, and let's do Dur. Because I'm on Windows, it's the equivalent of ls. So we press submit. Oh, we can see it's actually returning more. So that console command has actually run on this server, essentially. So what does that look like under the hood? You can see we use something called exec here. So this is a command in PHP that executes a console command. And this, in this case, it saves it to the output of a array here. And then it just prints it out. It's very straightforward, kind of. And this is one way you find RCEs, because you can, if people use a command like exec, there are other commands in different languages and in PHP itself. You can execute commands on a server. Now this can be quite useful for things like ping testing, especially if you've got a secret, or not secret, but private, say, intranet. You might use commands like exec to run things on the server. So what's then code injection? So this is code injection. If we submit this, we get a result. Now, code injection means we can inject code, in this case PHP, directly into this. So we got 1 + 1 = 2. So we can instead try doing PHP info. And we know that if 1 + 1 is working, then there's got to be a semicolon at the end. And here we go. PHP info just returns back all of the information about my local PHP. I just make it a little bit smaller so you can see what PHP info looks like. So this is useful, especially when we start talking about CVEs, no version numbers of things. So, okay, what's that code doing? So here we've got an input type that just has a very simple value, and we use the eval. So eval allows you to use basically PHP code in a string, so to take user input, for example. You'll see very much why you're not supposed to use this, but in this case we use it to do some maths, some 1 + 1, by simply making a variable maths equal to whatever post is, and then echoing out the value of maths, which is why that PHP info works. And you'll see here we've got PHP info 1. So we can actually write any PHP code here. If we write echo hello, and we do 1 + 1, so semicolon because it's a new line. Oh, unexpected echo. Oh, I probably should do it like this. We can kind of see that we're able to, that's the echo 1 there. But yeah, so that's kind of what some PHP examples of code injection and command injection. I will make this available if you want to have a look and have a play around with it. It's not a CTF, there are no flags. It is just so you can kind of see these working. So now we know kind of that RCEs are really either command injection or code injection, the ability to run server commands or the ability to add your own code to a page. So they are the two types of RCE, and as we go on we'll see these distinct types basically. The whole idea of RCE, remote code execution, really refers to code injection rather than command injection, but command injection is used pretty interchangeably. Alright, so what's the impact of an RCE? RCEs obviously have huge impacts. They often use a chain of vulnerabilities, and which is where one vulnerability leads to another, which leads to another, which then leads to the RCE. Meaning the actual application is vulnerable to like several different bugs, and RCEs are some of the fastest bugs to be triaged, paid out, and fixed because they are so dangerous. A lot of the times, as we'll see, these vulnerabilities are actually public. That even the attacker might not have actually written the POC, right? Proof of concept. So an RCE is just insane. But let's talk about when an impact of an RCE is NA. And Cody, very much in this tweet, kind of encapsulates why RCEs actually might not be a big deal. And he says, the moment when you achieve an RCE, only to find out you're in a sandbox environment where there are far more easier ways to get code execution, and it's completely out of scope since it's intentional. Moral of the story, read the goddamn program page. And here he elaborates and says it's intended functionality, but the ability to run code on the sandboxes. And then he's going to use the same method, trying to look for something in scope. So sometimes really an impact of an RCE is nothing, especially when developers intend code to be executed. They sandbox it. And if you're able to escape that sandbox, that's definitely a bug. So being able to go from like a sandbox environment to the main environment, bug. If you can't, sometimes RCEs have really little impact. You know, on some programs, the whole what the app is done, what the target can do, can make a usually lower level vulnerability in IDOR or business logic, cross-site scripting, worth more than an RCE in impact, especially if the RCE is sandboxed and the IDOR isn't, and the IDOR can lead to an account takeover, right? You can kind of see that just because an RCE is this super holy grail bug, and a lot of people think it's the gold standard of bug finding, actually, sometimes a lesser vulnerability can actually be worth far more. Just because of what an app is and what it does and what the industry is and stuff like that. So how do developers protect against RCEs? And really what we're asking here is, how do we know if something is vulnerable to an RCE? And really developers should listen to the documentation of the tools they use that say, hey, maybe don't do this. Both execute, EXEC, in PHP, and eval both have these warnings on the page that say, hey, maybe don't do this. Eval allows for arbitrary PHP code, and you shouldn't really put user supply data into an shell. The other kind of advice is really to keep software up to date to protect against CVEs. Don't worry, we're going to talk a lot about CVEs. And here from Image Tragick, we actually have some advice on how to stop Image Tragick from image management being vulnerable to the Image Tragick CVE. If you're familiar with RCEs and getting your first RCE, you've probably heard of Image Tragick, but once again, don't worry, we're going to go through it. This is just an example of a CVE, a security vulnerability that somebody else has done. They've told the software developer and they've patched it. However, in CVEs, if they use a lower version of software, it's obviously still vulnerable. And then sandbox code, like we said before. Check that the RCE isn't intended by the developer. You know, you've got those web pages where you can test your JavaScript. Maybe getting like an XSS on that is not a big deal, but getting an XSS on something where it's not intended is obviously much bigger of a deal. Okay, so RCEs and how to find them. Let's break down finding RCEs and how people do it. So we talked about what an RCE is and what an RCE is not, and the impact of an RCE. So let's talk about the technical details. Let's get into the real meat of RCEs. So where do you find RCEs? So RCEs are really found in a range of application. There's no sort of applications which are more vulnerable or less vulnerable. There's no industries that are more or less vulnerable. We're going to look at some common RCE locations in a bit. However, a lot of these are just random like apps that just take poorly sanitized inputs. Or if they have CVEs, again, software vulnerabilities that have already been disclosed and fixed by a company, and practice responsible disclosure, and taking those vulnerabilities and using them on older software. And they can really highlight vulnerable software. So let's see some examples. Here we have some lovely RCE examples. File uploads. If you've got a file upload, then you can upload a file. In this case, you're able to run a .terminal file on Mac, which doesn't have to be signed, for example, to be run. Hardware hacking, if you've got a local kind of intranet or something, or in this case, this is Ubiquiti, so I assume it's their kind of intranet for their Wi-Fi hubs. You can see like your Wi-Fi details and stuff like that. And then in this case, they used XSS to bypass some CSRF tokens. And known vulnerabilities in specific softwares like CVEs. Once again, talk more about them, don't worry, next slide. And then just in the code using a version of X, in this case this is SQL. So sometimes you will find developers who don't listen to that little warning that says maybe don't do this. So those are the locations that people find RCEs in. They aren't all the locations, they're just the ones that are the easiest for me to kind of explain without getting into like a whole bunch of security research. So I've talked a lot about CVEs, and if you're not familiar with what a CVE is, you're probably very confused. What is a CVE? Why is that important? What are you talking about? So what is a CVE? What is it? Why is it important? What am I talking about? So a CVE is this entry on the CVE Common Vulnerabilities and Exposures. And it's really a list of known software vulnerabilities. It assigns a number to a known vulnerability in a widely used code base. So, you know, you won't get it on, I don't know, Verizon Media's one of Verizon Media's targets like yahoo.com. You'll get it on something like WordPress, where a lot of people use that. And it really allows security people to disclose and build on other people's findings. So it allows them to disclose bugs and then also to build on them. And really it gives us a list of really easy bugs to find, especially as they include the version number. So if we're able to figure out what the version is, we can look for CVEs that match that version. However, as we'll see, just because we know what the bug is and we know it's there doesn't mean we're able to exploit it. Okay, so let's talk about Image Tragick. So Image Tragick, or CVE 2016-3714, is a vulnerability in a piece of software called Image Magick. Now, Image Magick is commonly used in many web apps to do image processing, reduce the size of files, crop them, make them turn, stuff like that. So it really lets you do some processing. Now, Image Magick is a command line tool which is implemented into PHP via gmagick, or is also implemented into other things. So it's not the case anymore, but you used to be able to upload an SVG or MGV file. And really you can inject commands into these because of the way that it processes it, right? So this is the example of, this one here is our MG file, and we can see here we've got, the actual, this is our valid kind of non-malicious code, but actually here this is our command injection, right? So and then we kind of have the same here with these ones. This is also our command injection. And this really just happens when the command line tool is processing this part here. When it makes this request to, deal with the image URL, it also, with this semicolon, will run the next command as well. So that's Image Tragick. And it's very well documented, it's very well understood, it still exists in a lot of applications because people use older versions of software even though they know how common it is. So this is one, and we'll see people use it in a bit, but this is one CVE that's very common. What about some other CVEs? So there are so many common CVEs that lead to RCEs on commonly used software. That's a lot. So if you've disclosed a bug or something on common software like Image Magick, there are so many of these, but usually these exist in kind of frameworks or development tools. Specific development tools will depend on language and what software it is and how it gets used and what kind of framework they need, and we'll kind of see how difficult it is in a bit. I mean, right now we've got the big Citrix CVE that came out a little while ago, and here we have, an example of how to use it to get bug hunting money. This won't really work because it was only disclosed recently and it hasn't actually had enough time for people to fix it, so you probably won't get paid out for that. Don't try that, it won't work. Okay, so that's all about what CVEs are, how to find them. Let's talk about using them. So when you see a CVE, it includes references, the quality of which for writing an exploit will really vary. So this CVE here has a full-on, well, here we have some references. So these are the resources that we can read to understand how the CVE works. And this one is a really great version of a POC because it's really detailed. It gives us a full working one. It gives us everything we need to send. It even includes something so we can tell. But often, you don't get them. You get this. You get a XSS vulnerability can be exploited. It doesn't tell us how. It doesn't tell us where. We don't know. These are not designed for bug hunters. They're designed for developers, and they're really there to be like, hey developers, update your fucking software, right? It's not complicated, it's not hard, but some of them, you can't necessarily write an exploit with these resources because they're so vague. You're just like, oh, what's the best practice? And this one here, like half of the thing is just look at how great we are. This is what our software does. So this is like the range. So we have our big range here of our detailed exploit and POC that we can use, and then we have some information. So if you don't have an exploit already there, how do you write an exploit? So often bug hunters need to custom write one. This is because not every time a developer has an exploit, or SP software has an exploit, does it work in the same way depending on what is there. So if you've got something like an XSS, obviously quite damaging, not very damaging if there's no user accounts, right? Like, what are you going to do with your XSS? You've got to try and figure out another way of sort of exploiting a website or app. So what a lot of RCEs people, when they find them, do is have to write custom exploits. And this is partly why RCEs can be so challenging to find. Some RCEs are very widely known, like we talked about Image Tragick, there's a few more, and some just aren't. Some are like really obscure software that hasn't been seen for 10 years, and the bug is like super weird, and it exists in like one endpoint, and you can't really access that endpoint. So there's a lot in taking an RCE from I found an RCE to I can exploit an RCE. And even if there isn't a custom exploit available, you may should customize it for your own use case. If you've got an exploit that will run commands, Linux commands are very different from Windows commands, so you have to customize it. And to write an exploit, what you really need to do is to understand the vulnerability. What causes it? Why it happens? What is happening on the server side? To just completely break down the vulnerability to its like core components. The second step is really to write working code. If you're not familiar with writing code, you can't find an RCE because you need to be able to write it. And then finally, you have to execute it successfully. You need to either go through your stages of whatever improving, and then actually get it working and get it working on the server. So that's kind of how CVEs and why they're really hard to find, how people use them. But if you want to learn more about using CVEs and exploiting CVEs, you need to start looking at what in academia is called state of the art. So this is an example of a DEF CON talk in a conference. A lot of research will make their known vulnerability research as CVEs public conferences like DEF CON. And they do that because it gives them a lot of cred, right? To talk in front of their peers and say, this is the bug, the exploit we found, and this is how it works. And in fact, you'll even see a bug report that was based on this research later on. And really these videos are great ways to understand how and why of writing a CVE exploit. Like we talked about how the vulnerability works, why it works, what happens on the server side. This is a great way to kind of understand, but also to keep at the forefront of what security research is like at the moment and what people are doing to be state of the art, to have that kind of link to state of the art work. So, in summary, how do people find RCEs? So, how are people actually finding RCEs? File uploads, known CVEs with well-written proof of concepts, especially Image Tragick, which is both. You have a file upload and a well-known CVE. And people find new CVEs where the fix is kind of new, like Citrix. People who find RCEs and who are finding the CVEs for the RCEs, wow, that's a lot. Finding the vulnerabilities for where you can execute something like an RCE are not bug bounty hunters. They are security researchers. They are the people reporting CVEs. They are at the top of their game and extremely knowledgeable professionals. These are not people who are going to, like, just be in it for the money is probably the wrong word, because I'm sure they do want to make money, but there is quite a different level from someone who's a bug bounty hunter, someone who's a security researcher, because if you're a researcher, you have to publish your research. That's how research works. And in security, we do that through CVEs. In science, we do it through papers. So let's talk about some RCEs in the wild. And really, I'm going from simple to more complex, but I've got some categories. I've included links once again, and I've put up the screenshots so you can read the screenshots, but all the links are in the description if you do want to read more. I highly suggest reading more about these. Like, my explanation of RCEs in this case are going to be so, like, completely simplified, because I have to get them in one slide and on a video, and if you look at the, like, actual write-ups, they are so good and you're just impressed, basically. I've also included a link to the Pentester Lab write-ups page, and that's really useful for finding write-ups rather than bug reports, because with bug reports it's usually a bit hidden, but write-ups is a lot more about the thought process. You can follow that. So first up, let's talk about Image Tragick and in general known CVEs. Image Tragick is obviously so widely found for finding RCEs. So let's talk about someone's first RCE. So this is by Res0, and it's called My First RCE, A Tale of Good Ideas and Good Friends. And I love this, like, report in general. It's so well written. Write-up. It's so well written, and I think it's really useful and to be fair, you won't get very far in bug bounties without making some really good friends, and friends with people who are like you, beginners, because you can bounce ideas off of one another. So I really want to start with someone's first RCE. So introducing Res0. So he kind of starts at looking at this really large data set of vulnerable domains, and this is provided by a friend he met off of Discord, and this is the Hacker 101 Discord. And really what he does is use fuzzing to discover new parameters. He's specifically looking for image, and he wants to find an image upload. And it's really simple, because all he did was try an Image Tragick payload and it worked. The difficulty in this RCE was doing all of these steps here, where what he has to do is actually find the location. But exploiting it is really easy, because it's a known exploit, POCs have already been written. My takeaway from this is really that you should make friends with other hackers. You know, join the community, take part, meet friends, new friends, meet old friends. By being part of a community, you'll really find that you can develop a lot quicker and you'll become a much better hacker overall. Another interesting thing here is the use of fuzzing. Now, I'm going to have a video on fuzzing out really soon. And what Res0 did was really this kind of mass fuzzing. He looked at a really large data set of vulnerable domains, and then he used a tool called Meg to kind kind of discover an image upload. But there's quite a lot you can do with fuzzing that he doesn't really talk about. But I thought it was a really interesting report, and I highly suggest reading it, because really, I cannot, explain this in a way that, he can. His write-up is so good. So that's Image Tragick. So let's look at another Image Tragick. So here, this is another write-up. This is by Strudnix. I'm going to go with that. So what this does is, instead of using what we've seen before, which is Image Tragick, kind of the default payload, just to prove it, actually this one has such a complex custom payload that I thought it was really important to bring up. So what has this done? This is find an image upload. Notice that there's a difference between the original image and the uploaded image, and that really suggests that image magic is being used behind the scenes. So try an Image Tragick payload using a blind method. So in here we do sleep 6, which delays our response by 6 seconds. So this is really how they decide. This bit here is, we know it's vulnerable to Image Tragick. The problem is really we need to write a custom exploit to get the result back, because we are just uploading an image. We need to actually exfiltrate something. We need to get some good stuff. And actually these steps here, they do it once to save a text file, then they do another time to exfiltrate the text file, and this is all using the custom exploit, and this is their custom exploit up here. So we can see at stage 1 what they're doing is they're writing ECT password to temp pwn text. So this then allows us, we know that temp pwn text definitely exists. Okay, so over here what we're doing is we're showing that, hey, we can then use wget and burp collaborator to then exfiltrate that and put it into burp collaborator, which he's got here, which is then our ECT password. So this is super interesting. Once again, for all of these, I am really not dumbing it down, but I'm really summarizing this, and you should definitely read the original. It's so good. So this is by Space Raccoon. And this is another example of a known CV, but this is not Image Tragick. This is exposed actuators and H2 database aliases in Spring Boot 2, which is a lot of words. And this is an example of known vulnerabilities. So the target uses a common piece of software called Spring Boot, a framework for Java apps. And what is a framework for software developers? It does a lot of the hard work for you. It lets them be more lazy. Software developers love to be lazy. Anytime they don't have to write something is good. So what's an actuator? We actually don't really care. It's a thing in Spring Boot 2. So find actuators, specifically actuator env. So what they do is, this is an endpoint that really shouldn't be public. It really lets you set new variables inside the app, which is useful for testing, not so useful for letting people not touch your app and add code to it. And really what Space Raccoon has done here is then injected his code. And interesting enough, if you look here, sorry, I know that this is super small, but this here is the final result, and we can see that he's put in once again, burp collaborator, but also this whole create alias s as concat. He's put in a payload that will block the firewall. So I thought that was super interesting. And then finally set your new variable to instead be some code, and then that is executed using exec, which is the Java version of exec, like in PHP, that we saw before. So here what we're doing is we're sending something to our burp collaborator instance. So pretty good. Exfiltrating data. Burp collaborator is used quite a lot in RCE stuff, just because it's really easy to exfiltrate data from it. I'm going to do a bit about it on some videos coming out, so don't worry. So next category is silly mistakes by developers. Now, yeah, developers make silly mistakes, and I've shown an example here of like my two like little tools which use some of the really dangerous PHP ones, and you wouldn't do that IRL. Like you wouldn't write malicious oh yes they would, developers totally would. This is an interesting one by Neeks. RCE by command line argument injection to GM convert and edit processes a crop. So this is not Image Magic, but instead Image Tragick, but Image Magic and some weird PHP. In this case, they found an image editing tool on Imgur, realized that it's using some kind of custom processing, either with Image Magic or with our friend escape shell command, which is really a version of exe from the very start of the presentation. So what they do is they inject code into the URL and the server will dutifully run it. So if we look here, we've got, this is our original parameter here, and it has a y value of 0 there. And all you do is you change the y value to be this, making the final y value from there to there, which is, that's our payload there. And then you send it, and it will be executed within, and you'll get an HTTP request to your server. Done. So, not necessarily Image Tragick, but instead just some weird image editing that uses a PHP. Realizing that, hey, if they're doing some custom processing, maybe they're using something like escape shell command or for example, execute, and then going, okay, here's my payload, please run it. And here's another example of insufficient sanitization, a little bit more complex, yet rather elegant, I thought. I thought this was very interesting. So environment variables are variables which are set by the operating system. If you've ever installed Java, you might have a check for Java _home. This is a very good example. But they're basically stored on the operating system. So this person, Miriam Bayou, what he's done is he's realized that the string close is really strict from commands to avoid being able to run them. However, if you set an environment variable like Java home to be equal to that character, like that, actually what you're able to do is inject that character into other payloads. So this is the steps to reproduce here. It's quite small, but you can read that while I explain it. So what you do is you create a new folder with the name of your payload and create a file. And the payload here is test and make directory boom. So why does this work? Well, if you imagine that our entire code is something like plus file name plus that and then whatever. When we inject file name, much like when we do SQL injection, what we need to do is we need to add an extra speech mark to enclose it. So our end payload is this plus whatever our malicious code here. So what we're doing, and the reason why we use this environment variable test, is to inject this thing in here because we know it's blocked by essentially the WAF. The WAF blocks it. Okay, so when you do that, you've basically got a really weird named file. But when you create a test file and you open it with Notepad++, what you do is you execute that command, which is our remote code execution. So therefore, what we end up with here is RCE, but in a really interesting way because they didn't sanitize they just stripped it like almost like client side, right? They just went, if string contains this, remove this, whatever, rather than actually stripping it from the end. So another interesting one. So let's talk about chaining vulnerabilities. Now, chaining vulnerabilities is used in so many different, more advanced bugs than what beginners find. Chaining vulnerabilities allows you to generate more impact from a single bug. Okay, so in RCE finding, chain vulnerabilities is super important because RCEs often aren't like the first endpoint you find. It's often like way deep. So let's look at another thing by Space Raccoon. I've used his reports twice, but he has a really nice style of writing, and I find it very useful to read. So this example is vulnerability chaining. So here we start with really finding the software, powering the server, and the version number, which is our 404 page. And when you look at that, the vulnerability, it's the version they're using is vulnerable to a known CVE. So use the results from running that vulnerability to find out more info on what the server is running. And when you look at that, the second one is also vulnerable to a known RCE. And finally, use a tool. In this case, it's a JEXBoss to exploit JBoss CVE and gain an RCE. Now, these CVEs were both discovered in 2007 and hadn't been fixed until hadn't been updated until Space Raccoon had reported it to Starbucks here. So don't just assume just because it's an old CVE that's not vulnerable to an old, but because it's been out there a while doesn't mean it's not vulnerable to older versions of software. And then we've got Orange Tsai, potential pre-auth RCE on Twitter VPN. I am not going to explain this. I really wanted to highlight how wild the CVE chains can get. This report uses 6 CVEs affecting the Pulse Secure SSL VPN. And a lot of them are sequential, which means he probably reported them at the same time or near enough at the same time. So here we can see arbitrary file reading, stack buffer overflow, command injection, arbitrary file reading, arbitrary file writing, session injection, all that come together to create an RCE. And this is extremely complex, so please read this blog or read the report and then watch the video because it's insanely complicated. I can't explain it. Not unless it would be a video all on its own. So let's talk about some takeaways from all of this. What can we learn from RCE write-ups? 1, finding RCEs is hard, and exploiting them can be even harder. Finding code which uses something like exec or eval in PHP is difficult because you don't really know what you're looking for. But actually you only find that through experience. You know, it takes a certain amount of experience to be able to look at a file upload and go, oh yes, that's probably vulnerable to this. Or their equivalent in other languages. So keep an eye out for file uploads. They're ripe with RCE potential, whether or not that's with Image Tragick or if it's just with a general file upload RCE and for outdated software. So let's talk about Image Tragick and updated software. Obviously, as we've learned, Image Tragick is the easiest and usually first RCE someone's found. But in general, outdated software is ripe with CVEs, usually with really well-written payloads that somebody else has already done. It's worth knowing the software and the software version of your target and being acutely aware of any CVEs associated with it. And really, I think some of the biggest takeaways for me are not the technical aspects, but instead about the mindset of finding RCEs. You have to get into the right RCE mindset. It requires a ton of skills to find and exploit, and it's easy if you have a pre-written POC that works 90% of the time. It's much harder to write custom exploits for known CVEs, and even harder to find those CVEs in the first place for the security researchers. And, you know, when you read a lot about how people find CVEs in the first place, you kind of realize how much creativity and ingenuity you really need to be able to do this. And honestly, some hackers, it's so wild how talented and how they can just find these, and it's like they have a second sense for it. And I think even by doing this video, I have a lot more respect for the finding of CVEs in general and how difficult it must be. So with that in mind, that's the end of the video. I hope you found this useful or interesting, or just to give you something to fill up a few minutes of your day. I've included links to everything in the description so you can have a read and read further. I'm going to include some more further reading as well. just in case you want to sort of take what I've talked about in this video and do some more research, I thought I'd give you somewhere to start. So I hope you really like this new series. Please give me any feedback you had. Did you like the series? Did you like the content? Did you like the way it was explained? I'm always after useful feedback and trying to improve these videos and work out what's the best thing I can really talk about and adjusting my explanations so it's really clear and understandable. So thank you for watching. Have a great day.